US Physics Olympiad year 2015 USAPHO Final Round. Problem A2. Consider the circuit shown below. IS is a constant current source, meaning that no matter what device is connected between points A and B, the current provided by the constant current source is the same. Question A. Connect an ideal voltmeter between A and B. Determine the voltage reading in terms of any or all of R and the IS. Question B. Connect instead an ideal ammeter between A and B. Determine the current in terms of any or all of R and IS. Question C. It turns out that it is possible to replace the above circuit with a new circuit as follows. From the point of view of any passive resistance that is connected between A and B, the circuits are identical. You don't need to prove this statement, but you do need to find IT and RT in terms of any or all of R and IS. Solution for question A. Using voltmeter between points A and B equivalent to using infinite resistance here. So we can replace this picture by equivalent picture. And due to symmetry, we have the same current IS over 2 through both branches. And now we can count what is the potential difference between A and B. Suppose that the potential of bottom part is 0. It means that the potential in point A will be IS multiplied by R, and the potential in point B will be 2ISR, and the potential difference will be UB minus UA, which is IS multiplied by R. That's the answer for question A. Solution for question B. Using ammeter means that we are creating shortcut between A and B, and we can change this picture for equivalent. Due to symmetry, we have current I1 is going through resistor 4A in the up left corner and in the lower right corner, and the current I2 is going through resistor 2R in the upper right corner and the lower left corner. And suppose that current I3 is going to the left. Now we can write three equations to find what are all these currents. Current I1 plus I2 equal IS. That's the first equation. Current I2, which is going here, it is split to I3 and I1, which is the second equation. And the third equation is potential difference between this point and this point. We can get from this way, which is 4RI1, this one, or we can go by this way, which is 6RI3 plus 2RI2, which is this way. So we have three equations and three unknown currents, and we can solve this system. Now we can exclude I2 and put it in first and third equations. We have these two equations, and from here we can find that I1 equal 4I3, and we put it in this equation, and finally get that I3 equal IS over 9. Let's answer for question B. Part C. If we don't need to prove this statement, we can just use results from A and B parts. Suppose that here we put a shortcut. It means that the current here will be IS over 9. And because it's full current, this source must have this current IS over 9. And now suppose that here we put infinite resistance. In that case, voltage will be IS multiplied by R, which must be equal IT multiplied by RT. And from here we can find that RT equal 9 times R. So that's the answer for question C.